Welcome to School of Advanced Chemistry. I am Octet. Today I am going to discuss Cambridge AS level chemistry, paper 1 multiple choice questions, Feb March 2020 1-2 variant. Let's get started. For each question there are 4 possible answers A, B, C and D. Choose one that you consider to be correct. Use of the data booklet may be appropriate for some questions. Question number 1. What number of protons, neutrons and electrons are present in the ion of Fe3 positive ion that is having 54 mass? So what is the number of electrons, number of protons, number of neutron? From the data booklet you can see that this Fe4 is having 26 atomic number. It is having 26 atomic number. Let's see over here. Here is the iron. It is having 26 atomic number. So 26 over here, the proton number is equal to 26. What is the mass number? That is 54. And now we can find the answer of neutron with the help of this mass number. 54 minus 26, that is equal to 28. Number of electron is equal to number of protons minus charge, that is equal to plus 3. Number of proton is equal to 26. So 26 minus 3, that is equal to 23, that is the number of electron. So the correct option is 26, 28 and 23. The first one, A1, so A is the correct option. A is the correct option. Question number 2. For which hydrocarbon are the molecular and empirical formula same? Butane, ethane, pent-1-ene, propane. For butane, C4H10. It's having molecular formula C4H10. We can simplify this formula by dividing 2 on these both number. We will be having C2H5. It's empirical formula. The next one is ethane, C2H6. The empirical formula will be again divided by 2. It will be CH3. It's empirical formula. Pent-1-ene, 5 carbon, 10 hydrogen, that is pentene. Its empirical formula will be divided by 5. It will be CH2 is its empirical formula. Propane, the last one, C3H8, and the common number is only 1, divided by 1. Again it's having C3H8, that is its empirical formula. So in this case the molecular formula and empirical formula both are the same one. So D is the correct option. D is the correct option. The next question, question number 3. Which molecule does not have any 90 degree or 180 degree bond angle? Which molecule does not have any 90 degree or 180 degree bond angles? And number 1 is C2H6. C2H6. So here's the hydrogen, 3 hydrogen over here. And how many bond pairs surrounding this carbon atom? That is equal to 4 bond pairs. And in case of these 4 bond pair, you can see that all the bond pair and bond angle will be 109.5 degree approximately. Again in the same case, there is the same case for this carbon. It is also showing 109.5 degree. So it's not having any sort of 90 degree or 180 degree bond angle. So its answer, I think that is A is the correct option. A is the correct option. However, we can check the rest of the options. CO2 is CO2. It's having 180 degree between these two bond pairs. Two sigma bond pairs. It is having 180. PF5. P is having 3F over here. It is a P5 type molecule, you can say, and 2F are lying above and below the plane. So 5F over here, between these 3F, the bond angle is equal to 120 degree, and here is 180 degree, and between these 2F is 90 degree. So again, this is not the correct option. SF6, it's octahedral molecule. As F, these all four are lying at 90 degree, and one F is above and one F is below the plane. So it's showing 180 degree and 90 degree. Again, this is the incorrect option. So it is confirmed that A is the correct option. Question number 4, the next one. Following data are needed for this question. Reaction of NaCO3 with HCl to make NaCl plus H2O plus CO2, and here is the answer of its enthalpy change. And let me erase the first portion. Sodium carbonate plus 2 mole of HCl goes to 2 NaCl plus H2O plus CO2, that is equal to delta H minus 96.59 kilojoules per mole. On heating, sodium hydrogen carbonate decomposes as shown. It's a sodium hydrogen carbonate, and it is going to change into sodium carbonate plus H2O plus CO2. What is the enthalpy change for this decomposition? So here are two given equations, and I'm going to connect these two equations with this one. This is the final equation for which we are going to find the answer, enthalpy change, delta H, or you can say, and in this case, we are going to connect these two equations. NaHCO3 plus HCl, we can add HCl into NaHCO3, and we can make NaCl plus H2O liquid plus CO2 gas. But this time we are using 2 mole of sodium bicarbonate. Here I'm using, here the given is 1 mole. And according to 1 mole, the answer is minus 38.97. With respect to 2, it will be 2 into minus 38.97. Now, you can highlight these, as one of the product, the basic common products, you can say. Sodium bicarbonate, again, it may react with HCl in the second equation with the 2 mole of HCl, right? And it may change HCl and it may change into NaCl, that is equal to 2 mole of NaCl, and H2O once again, and CO2. So I have connected these two equations with the last one equation. Now we have completed a cycle, and the answer of this equation, that is starting from the 1 mole of sodium carbonate, is equal to minus 96.59, and we are supposed to find the answer of the first one. So I'm using my own rule, His rule, that this vector, this arrow is, let's suppose, the vector 1, and I'm going to use head to tail rule method to add these vectors or to find the sum of this vector. This vector must be the resultant vector. Its tail should be connected with the tail of other vector, and its head should be connected with the head of other vector, but that is not the case in this vector. So I have to flip this vector to make this vector that is going to be a resultant vector. So I am going to flip this vector. After flipping this vector, its magnitude, its answer will also be flipped. So now its value has become plus 96.59, and it's having the same magnitude. So delta HR in this case that is equal to delta HR in this case is equal to plus 96.59 plus into bracket 2 multiplied by minus 38.97. So here is the answer of this reaction, and answer is 18.65. So C is the correct option. C is the correct option. The next question, question number 5. In the redox reaction, how do the oxidation state of the vanadium and sulfur changes? In this case, VO2 1 positive plus SO2 goes to V3 positive, SO4 2 negative. In case of VO2 1 positive, I mean VO2 that is equal to 1 positive. Here are two elements. I am going to divide into two parts. Here is the -4 for oxygen, and there must be +5 for vanadium to make the sum equal to +1. So in this case, this vanadium is +5. What about SO2? SO2 for oxygen it is -4, for sulfur it will be +4 to make the sum equal to 0. So +4 and for oxygen is +4 over here. In this case, this ion, this charge is the same as that of its oxidation state. In SO4 2 negative ion, SO4 2 negative mean my answer should be the 2 negative. The sum of the oxidation states of these two elements must be equal to 2 negative. -8 and here should be +6. So initially sulfur was +4. Here it is in form of +6. So it has been oxidized. And in case of vanadium from +5 to +3 or 3 plus you can say. So the change in oxidation state is +5 to 3, +5 to 3, either C or the D is the correct option. And in this case you can see that 4 to 6, so it is confirmed that D is the correct option for question number 5. Question number 6, the equation for the reaction between silver chloride and aqueous ammonia is shown over here. Silver chloride, and here is the ammonia for the formation of a complex, diamino silver complex, and Cl negative ion formation takes place. What are the units for the Kc for this reaction? You know, in the expression of Kc, we never include the solids and the pure liquid. So in this case, aqueous, and aqueous, its expression will be equal to, first of all, concentration of this complex, silver diamino complex, and that is having one positive charge complex, and this, the last square bracket is showing the mole per dm cube, multiply by one bracket for the Cl negative ion concentration, divided by here is the concentration of ammonia, and there must be the square because of 2 mole of ammonia in the equation. So 2 brackets are in numerator and 2 brackets are in denominator. So there will be the cancellation of these brackets. There will be no unit for this reaction. So for 6, A is the correct option. Question number 7. Sodium azide decomposes as shown. Sodium azide, 2 mole of sodium azide is going to decompose to make 2 mole of sodium and 3 mole of nitrogen. Which volume of nitrogen measured at room temperature and pressure? Room temperature and pressure mean, you know that at room temperature 1 mole is equal to, any gas of 1 mole is equal to 24 dm cube. What will be produced by the decomposition of 150 gram of sodium azide? As you know, the reference is sodium azide, and he is asking to find the gas, that is the volume of this gas. This is nitrogen. So the computation is in between sodium azide versus N2. Number one, I'm going to use unitary method, you can say, or the ratio proportion method. From sodium azide, what is the given mass of sodium azide from the balanced chemical equation? I mean, 2 sodium are here, 2 into 23, plus 2 3s are 6 nitrogens are here, 6 into 14. What is the MR? Let me check it first. 23 multiplied by 2 plus 6 multiplied by 14, and the answer is equal to 130. The answer is equal to 130. So 130 is the MR according to the balanced chemical equation. According to balanced chemical equation, 130 gram of sodium azide is going to liberate 3 mole of nitrogen, and you know 1 mole is equal to 24 dm cube. What will be the volume? 3 into 24, I mean it will be equal to 72. It will be equal to 72. 24 multiplied by 3, that is equal to, yes, 72. And 130 gram is going to yield 72 dm cube. And if we are using 1 gram, 72 over 130, and at the spot we are using 150 gram. We are using 150 gram, 72 over 130 into 150. So 72 multiplied by 150 divided by 130, then the answer is equal to 83.0. I mean B is the correct option. B is the correct option. Question number 8. A stable ion, that is N5 positive ion, has been produced by a research chemist. Which structure is most likely to show the electronic arrangement of this ion? I mean, the basic route is you must be following the octet rule. Octet rule, and number of electron should be, I mean, consider in this case number of electron, you can say the outer electron. Number of outer electron also should be the compatible with as that of the formula. So 5 nitrogens are over here. I mean, 1 nitrogen is hosting 5 electron in its last shell. 5 nitrogen, 5 5s are 15 electrons should be there. There is a 1 positive charge, mean there is loss of 1 electron. Overall electron in the last shell of these 5 nitrogen atoms should be equal to 14, number 1. The next thing is we should follow up to the maximum level, that is octet rule. So in case there are the 4 options A, B, C and D. A, B, C and D. And here is, let's see, what are the total number of electrons? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. Yes, number of electrons are equal. Now come to the next one. Each nitrogen atom must have complete octet. In this case, 1, 1, 1. I mean 6 electrons are there, octet is not complete, right? This nitrogen is having incomplete octet. 2, 3, 1, 2, 3, and I mean 6 plus 7, again there is incomplete octet. So this is the incorrect option, you can see. Come toward the next option, that is the B1. In this case, 1, 2, 3, and again 1. I mean 7 electrons are there. This nitrogen is also not having the complete octet. So again, this is the incorrect option. Come towards the option C. In this case, 2, 2, 2, 2. I mean 8 electrons are there. 8 electrons are there in its proximity, in its last shell. Come towards this nitrogen, and 2, 2, 2, 2. Again 8 electrons are there. Come toward the next nitrogen, 8, 2, 2, 2, and 2. 8 electrons are there. In next nitrogen, I mean in this one, 2, 2, 2, 2. Again 8 electrons are there. And in the last nitrogen, 2, 2, 2, and 2. I mean, again 8 electrons are there. So all nitrogens are having octet, they are following the octet rule. I mean, they are having 8 electron in their last shell. Now come towards the number of electron: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. Yes, C is the correct option. So there is the method, this is the method to find the answer like that, questions like that. Question number 9. 1.8 gram of water heated 2 to 7 degrees Celsius in the sealed container turns to steam with a pressure of 200 kilopascal. What is the approximate volume of the container, right? You are having the quantity of the, substance, that is water, and you can change it into moles. Here is the temperature in centigrade in a sealed container, and the pressure is over here. So mole, temperature, pressure, and he is asking the volume. So you can apply PV is equal to nRT. PV is equal to N into R into T. Let's suppose this water sample is going to behave as an ideal gaseous sample. In this case, the pressure is equal to 200 kilopascal, but we are not allowed to use in kilopascal, we will use in pascal. 200 into 1000, and we are supposed to find the volume, that is equal to number of mole. 1.8 over 18 multiplied by R. R is having 8.31, and multiply by its temperature. It must be in Kelvin. 277 plus 273. So volume will be equal to, you can say 1.8 multiplied by 8.31 multiplied by this sum, that is equal to, just a minute, 277 plus 273, and it's equal to 550. It's equal to 550, and divided by 20000 multiplied by 18. 2 into 10 to the power minus 3. So B is the correct option. So B is the correct option. Question number 10. When the equation is correctly balanced, what is the value of C? When this equation is correctly balanced, what is the value of C? Let me read it first. So we are going to balance this chemical equation first. The basic method is you should balance the charges on the both side, and here you can see that here are two positive charges, and here the charges are one positive and two negative. So overall, if there is one more negative charge, here are two positive and one more negative. So I'm going to multiply this hydrogen positive ion, with 4. So now the sum on the left hand side is equal to, the sum of the charges is equal to 2 plus or plus 2, and here once again it is also having 2 plus or plus 2. The next one is now here are 2 magnet, 2 Mn, so we will write 2 over here to balance the magnet, and again we have disturbed this positive ion. 2 are 4 positive ions are there, and there are yet, you can say, the 2 negative plus 4, 2 positive ions. So we will have to change this once again, and I am going to multiply it by 6. So 6 positive ion, 2 negative ion, and overall that is equal to 4 positive ion. Yes, now the both sides are having same number of charges. The next one, again you can balance the hydrogen, C2H4, and however we have find the answer, this one, the mole, that is equal to 6. So D is the correct option. And you can balance the whole equation. So 2 carbon, 6 hydrogen, 2 oxygen. Let me check oxygens. 2 fours are 8, and here is the 1. Overall 9 oxygens are there. 9 oxygens are there, and here is only 2 oxygen. So we have to multiply to balance this oxygen first into even number. I am putting 2 over here. Now the oxygen atom is equal to 10. 4 to the 8 plus 2, that is equal to 10, and I am putting 5 over here. And now oxygens are balanced, right? And if you are putting 5 over here, then you will have to again write the 5 over here. I think now the whole atoms, all atoms, oxygen, hydrogen, manganese, all atoms are balanced, and charges are also balanced. Once again, hydrogen is equal to the mole of H positive ion is equal to 6, that is the C1, and the value of C is equal to 6, and D is the correct option. This is the balanced chemical equation. The whole equation is balanced now, and we are having C is equal to 6. So D is the correct option. Question number 11. The main stage in contact process is an equilibrium reaction. 2SO2 plus oxygen goes to 2 mole of SO3. Which rule describe the effect named conditions on the equilibrium yield? Presence of catalyst. What is the effect of catalyst? It increases the yield. No, it never increases the yield. It has no effect on the yield. Either A or the B, the correct options. High pressure, if you are going to increase the pressure, 3 moles are over here and 2 moles are over here. So by increasing the pressure, equilibrium will shift towards the right hand side. There will be more yield. There will be more yield. Yield will be increased, yes. High temperature, and this reaction is exothermic reaction. Its answer of its enthalpy change is negative. So by increasing the temperature, equilibrium will shift towards the backward, towards the side of the reaction, and its yield will be decreased. So B is the correct option. Question number 12. X and Y are oxide of the different period 3 elements. If 1 mole of X is added to the water, the solution formed is neutralized by exactly 1 mole of Y. What could be the identity of X and Y? Again, X and Y are oxide of the different period 3 elements. If 1 mole of X is added, 1 mole of this one is added into the water, solution form is neutralized by exactly 1 mole of Y. When this 1 mole of any of P4O10, SO3 is added into the water, then any of 1 mole is going to react with this one, and 1 mole of Y is going to react with this one. So first of all, if we put 1 mole of P4O10 in water, in H2O, we will get H3PO4. Let me balance this chemical equation. 4 should be there to balance the phosphorus, and now here are 12 hydrogen. I am putting 6 over here. How many hydrogen? 12 hydrogens are there. 4 are 16 oxygen. Equation is balanced. So if you are going to dissolve, or you are dissolving 1 mole of P4O10, there is the formation of 4 mole of H3PO4. In case of SO3, if you are going to dissolve 1 mole of SO3 into the water, there is the formation of H2SO4, 1 mole of H2SO4. Now come toward the next options. Na2O and with H2SO4 plus H2SO4. What should be the answer? Answer should be Na2SO4 plus H2O. So 1 mole of Na2O is going to react with 1 mole of H2SO4. There is 1 to 1 ratio. 1 mole of X is added into the water, and it is neutralized exactly by the 1 mole of Y. So 1 mole, and it is also the 1 mole sodium oxide and H2SO4, that is basically going to form from SO3. So this T1 is the correct option. This T1 is the correct option. If you are using this one acid with Na2O or with Al2O3, then definitely the mole ratio will not be equal to 1 ratio. For example, if you are using Na2O with 4 mole of H3PO4, then there might be possible for the formation of Na3PO4 plus H2O, right? So to balance this chemical equation, I'm going to write 2 over here, 3 over here, and 2 over here. How many phosphorus? 4 phosphorus are there, 4 over here. There must be the 4 over here. So 6 should be over here, and 4 Na3PO4. And the next one is, how many hydrogen should be there? 3 4s are 12. 6 H2O should be there, and 6 oxygen, 4 PO4. Yes, now this is the balanced chemical equation. Now you can see that 6 mole of Na2O and 4 mole of H3O is going to form. The ratio is not 1 ratio 1. Ratio is not 1 ratio 1. In the last one, you can also check Al2O3 with H2SO4, Al2O3 with H2SO4. There will be the formation of aluminium sulfate, that is Al2SO4 thrice. 2 aluminium and 3 SO4. So 3 H2SO4 should be there, and we will H2O, that is equal to 6 H2O, and 6 H2O. This is just a balanced chemical equation. You can see that I think it's 3 oxygen is over here and SO4 are over here, 3 H2 over here. Yes, now this is the balanced equation. Now the mole ratio is equal to 1 ratio 3, not 1 ratio 1. So it is confirmed that D is the correct option. Question number 13, compound C is insoluble in water but soluble at low pH. It is not soluble in water, but it is soluble in acid. Low pH means it is soluble in acid. What could be compound Z? Barium carbonate, barium chloride, barium hydroxide, barium sulfate. Let's see, all the metal carbonate except group 1 and except ammonium ion, they are insoluble in water. And all carbonate react with acid to make CO2, to make water, to make salt. So the first one option is the correct option. It is insoluble in water, but it reacts with the acid to make CO2, H2O and salt. So A is the correct option. Question number, next one, 14. Hot aqueous sodium hydroxide reacts with chlorine, 6 mole of NaOH, 3 mole of Cl2, 5 mole of NaCl, 1 mole of NaClO3 and 3 mole of H2O. Which statement is correct? Oxygen number of chlorine and hydrogen both changes in this reaction. No. Oxidation state of chlorine changes only. This is the example of disproportionation reaction. So first one is the wrong one. Only chlorine changes its oxidation state, not the hydrogen. Oxidation number of the chlorine in the product are -1 and +1. In this case, it is -1. In this case, it is 6 minus for oxygen, +1 for sodium, and +5. No, it is again incorrect. it is not +1. If the aqueous sodium hydroxide is cold, reaction produces NaClO instead of NaClO3. Yes, it is correct. When cold NaOH is added to the Cl2, then is the formation of NaCl, NaClO, and H2O. Three substances are going to form in this case. So C is the correct option. C is the correct option. Question number 15. Solid ammonium nitrate is put into test tube and solution X is added to it. The resulting mixture is formed. The gas given off is tested with the damp red litmus paper. You know, damp red litmus paper is used to test the gas that is usually, as far as our syllabus is concerned, is ammonia gas. The litmus paper changes color from red to blue. Yes. What could be the identity of X and its role in the reaction? Once again, solid ammonium nitrate is put into the test tube and solution X. Bases are supposed to react with all type of ammonium nitrate, ammonium chloride, ammonium salt, and when the bases are allowed to react with ammonium salt, they produce NH3 gas plus H2O plus salt. So it must be a base. It must be a base. And as you know, if it is behaving as a base, what is the function? What is the role of a base? You know, what is the role of a base? To proton acceptor, not the proton donor. So proton donor is incorrect. A or B were the two possible options, but this is the not role of the base. This is the role of a base. It is accepting proton. Bases are always proton acceptor. So B is the correct option. Question number 16. Sodium, magnesium, aluminium are three elements in the period 3 of the periodic table. Each element forms an oxide. Which row is correct? Sodium oxide is basic. Yes, it is true. It's making the giant basic. It's a giant ionic. Yes, it is true. High melting point, readily reacts with water. Yes, all the options in this column are the correct one. Magnesium oxide. What about this one? This magnesium oxide is amphoteric. No, it's not amphoteric. It's a giant ionic. Yes, it is having high melting point. Yes. Slight reaction with water. Slight reaction. Yes, it is the true. Aluminium oxide is amphoteric. Yes. Simple molecular structure? No, it's an ionic, giant ionic structure. Low melting point? No. No reaction with water? Yes. So the last line is having all the correct options. So D is the correct option in this case. Question number 17. A student investigates calcium nitrate crystal by heating them in apparatus shown. A colorless gas leaves apparatus at Y. A flame is held to this gas. So here is the decomposition of the calcium nitrate that is supposed to make when calcium nitrate is heated. Calcium nitrate upon heating give calcium oxide plus 2 mole of nitrogen dioxide and half mole of oxygen, right? Half mole of oxygen. So this gas must be the oxygen, right? Water with few drop of the litmus, and you know NO2 is water soluble. It will remain inside the water and it is an acidic gas, you know. So which one option is the correct option? Let's see over here. Over here. Number 1, litmus solution changes to blue. No, it will not change to blue because this NO2 gas is not the alkaline gas. B changes to blue, again it's incorrect. C changes to red, yes. D changes to red, yes, it may be the correct as well. What about the flame of Y? Flame burns more brightly, flame goes out. Oxygen helps in burning. it will relight the glowing splint, or the lighter splint will be more brighter in the presence of oxygen. So flame burns more brightly, and C is the correct option. The next question is question number 18. How does concentrated sulfuric acid behave when it reacts with the sodium chloride? You know that when the sodium chloride is allowed to react with concentrated H2SO4, there is the formation of Na2SO4 finally, and white fumes of HCl formation, HCl gas formation is there. NaCl, H2SO4 is not a redox reaction. There are the two possible reactions. Number one, step one is, in this case, it's an acid-base reaction. It's an acid-base reaction, and it could be the redox, but at the moment it is not a redox reaction. It is not a redox reaction. So, not a redox. I mean, the sulfuric acid is behaving as an acid. Yes, it is true. It is going to make a salt, and it is an oxidizing agent. No any sort of oxidation or reduction. So it is confirmed that A is the correct option. In this case, the sulfuric acid is acting as an acid, and this NaCl is acting as a base. So this is an acid-base reaction. Question number 19. Which statement about nitrogen and its compound is correct? In a Haber process, the temperature is kept high to give a good equilibrium yield of ammonia. As you know, Haber process is an exothermic reaction, so high temperature will give the poor yield at equilibrium. So this is incorrect. Nitrogen gas is unreactive because it's strong nitrogen-nitrogen double bond. No, there is no double. I mean, there are triple bond. There are triple bond. So B is also incorrect option. C, nitrogen monoxide will react with carbon monoxide under suitable condition. Nitrogen monoxide will react with carbon monoxide under a suitable condition. Yes, it is possible, as you have seen in the catalytic converter. Nitrogen monoxide may react with the carbon monoxide to give CO2 plus N2. I mean, 2 mole of nitrogen monoxide may react with the carbon monoxide, that may be equal to 2 mole, and 2 mole of CO2 formation take place, and 1 mole of nitrogen. Yes, it is correct. So C is the possible option. However, let us check the D. The formula of ammonium sulfate is NH4SO4. No, it's wrong. Its formula is NH4 twice SO4, because its ammonium ion is having 1 positive charge and SO4 is having 2 negative charge, or -2, you can say. -2. Question number next one, 20. Which pair of compounds are functional group isomer of each other? Butane 1-ol and butanol. Functional group isomers mean compound having the same molecular formula, but they are different with respect to the functional group. Butane 1-ol, this is butane 1-ol. I mean, the first carbon is having OH group. There are 2 hydrogen, and CH3. Versus butanol, it's CH3, CH2, C double bond H. So they both are not having the same molecular formula. Here are 1, 2, 3, 4 carbon atoms are there. C4, and how many hydrogens are there? 10 hydrogen, 1 oxygen, right? And in this case, you can see that 4 carbons are there, 5 plus 3, 8 hydrogens and 1 oxygen. So the formula is not similar. I mean, this is incorrect option. Ethyl propanoate and pentanoic acid. Pentanoic acid mean CH3, CH2, CH2, and CH2, C double bond OH. This is a pentanoic acid, and it's having 5 carbon atoms, 5 plus 4 plus 1, 5, 10 hydrogen and 2 oxygen. So its formula is equal to 2. The next one option is ethyl propanoate, and this is the ethyl propanoate. CH3 and CH2, C double bond, O, O, CH2, CH3. Ethyl propanoate, 5 carbons, and hydrogen is equal to 10 hydrogen and 2 oxygen. Yes, both are having the same molecular formula, but they both are having the different IUPAC names. So if the name is different, the compound is different, the structure is different. So yes, they can be called as the functional group isomers. I mean, B is the correct option. Come towards the question number 21. Which row identifies a suitable starting material and reagent that can be used to produce butane nitrile? What is the butane nitrile? This is the formula of butane nitrile: CH3, CH2, CH2, C triple bond N. So this is the nitrile that can be made from a haloalkane. So halogen is replaced, or halogen is substituted by CN group, right? So in this case, you can say that there must be 3 carbon halogens. 1 carbon is because of this nitrile group, and 3 carbon halogens, either A or B, should be the correct answer. But in this case, you can say reagent must be group 1 cyanide, not the HCN. HCN is used for aldehyde and ketone. So NaCN, or the potassium cyanide, is the appropriate reagent, and the halogen must be 1 less carbon. I mean, overall there are 4 carbons, 1 less carbon, I mean 3 carbon halogen should be there. So B is the correct option. The next one is question number 22. The diagram shows the structure of ethanoic acid, that is the ethanoic acid, ethane dioic acid, reacted with ethanol in the presence of few drops of concentrated sulfuric acid to form a diester. The molecular formula of the diester is equal to C6H10O4. What is the structure formula of the diester? Let me check the formula of this dioic acid. It's having only 2 carbons, and I mean 2 OH group, 2 oxygen. So when this dioic acid is allowed to react with the other one, there is the loss of OH group, and there will be the new oxygen from the alcohols. How many total carbons are there? 6 carbon. So there must be 2 carbon on the both side. 2 carbon on the both side. So CH3, CH2, CH2, CH3. I think this is the diester, if I'm not wrong. How many carbons are there? 6 carbon. How many hydrogen are there? 10 hydrogen. How many oxygen? 4 oxygen, yes. So it means that when this is allowed to react with ethanol, this part came from the ethanol. When it is allowed to react with the ethanol, this diester is going to be formed. What is the formula of diester? Here it is, and you can see that you can compare it with A, B, C, D with the 4 options. A, B, C, D. Which one is the correct option? Let me check it over here. CO2. No, it's not the correct one. Basically, CH3, CH2. This should be CH3, CH2, then oxygen, then carbon, then again oxygen, then again carbon, and then oxygen, CH2, CH3. We write the formula starting from left to right. Okay, which one is the correct formula? I mean, the correct one option is this B1. B1 is the correct formula, correct option. Question number 23. The infrared spectrum shown was obtained from a compound J. This is a spectrum, and I'm going to divide this spectrum into roughly into two parts. So there are basically 2 strong signals, number 1, number 2. Now this signal almost is in the proximity of, you can say, in the proximity of, or roundabout, you can say that is equal to 1, 2, 3, 3,500, you can say. And this one is in the proximity of, or in, that is closer to the 1650 or something like that. So now come toward the options. Where statement about J is correct. Both C double bond O and C triple bond N are present. Just have a look on the data booklet. Here is the data booklet, and C double bond O is over here. That may be the imide and ketone, aldehyde, carboxylic acid, ester. They all are having C double bond O. And the range of the C double bond O is a strong, it's showing the strong signals, and range is 1640 to 1690, 1670 to almost 650 or 640 to 1750. So this is the range, and it is confirmed from the picture that yes, it is having C double bond O. It's having C double bond O group. Now come towards the presence of C triple bond N. C triple bond N, that is the nitrile, and it is supposed to show its present around 2200 to 2250. 2200 to 2250, 2250. So there is no any sort of peak, such peak in this case. 2200 to 2250. No, it should be in this region, and there is no presence of any Cn negative ion. So first one is incorrect. Neither CO nor C triple bond N, no, CO is present, so it's incorrect. CO is present but not Cn. Yes, it is correct. C double bond O is present, but the C triple bond is missing. So C is the correct option. Question number, the next one, 24. A section of the polymer chain is shown. What is its correct monomer? What is its correct monomer? Let's see how to draw its monomer. I'm going to draw its monomer. Give me 1 minute. For example, this is the bond that is showing the continuity of the chain. These two bonds are showing the continuity of the chain of this polymer. I'm going to delete or erase these bonds. I'm going to erase these bonds. I'm going to remove these bonds, and I'm going to shift these bonds over here. I'm going to shift this bond over here. So this bond was shifted over here. At that time, again, I'm going to delete this one that was the previously shifted, and at that time you can see that again I should have removed it. We should remove it completely. So, and in this case again there must be a double bond. One double bond should be over here. This bond is shifted over here. This bond will be shifted over here, and I'm going to erase this bond. I'm going to make this bond in a reverse mode. I'm shifting this bond in a reverse way, you can say. So double bond is over here. So these, and again this bond will be shifted. This bond will also be erased. This bond will also be removed, and so on. So we are having this one structure. CH3, and it's CH double bond. It's C only. It's CH2. It's CH3. It's CH3. It's CH, and it is CH3. So let's see what is its name, or what is the basic arrangement of this monomer. Basic arrangement of this monomer as this one. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. It's having 5 carbon atoms, the longest chain, And the next one is how many branches are there? How many branches are there? Let's suppose if I'm starting from this terminal to this terminal, so 1 and 2. 2 branches are there, one is a double bond. So you can say that. And yes, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 2 branches are there. How many carbons are there? 1, 2, 3, 4, 5, 6, 7, 8 carbons are there. 1, 2, 3, 4, 5, 6, 7, 8. Yes, 8 carbons are there. And this double bond position is from this terminal. You can say it's carbon number 1, is carbon number 2, is carbon number 3. And the position of the double bond is equal to 2. 1, 2, 3 is 2. Yes, A is the correct option. So in this way, you can make, you can synthesize, you can confirm the actual monomer that was added up. In this case, in case of B, definitely the structure is not similar and the position of double bond is not similar. The position of double bond must be at 2 position, 1, 2 and 3 from here and 1, 2, 3 from here. It is the incorrect one. Come toward this C1, 1, 2, 3, 1, 2, 3, again it is incorrect. In case of D, the longest chain is having double bond, but again the position of double bond is not the 2, 1, 2 and 3. From here you can say 1, 2 and 3. So again it is confirmed that A is the correct option. Question number 25. Structural isomerism and stereoisomerism should be considered when answering this question. How many non-cyclic isomer have molecular formula C5H10? I mean non-cyclic, it's having carbon double bond because carbon and hydrogen are in 1:2 ratio, 5:10, I mean 1:2. And non-cyclic, there must be no any sort of the cyclic, I mean there must not be any cyclopentane. So if it's non-cyclic, so it should be the alkene. Let's see if the 5 carbons are there. There are basically 2 basic possibilities for alkenes. Number 1, in state chain, I mean with the 5 carbon atom. This state chain is having the 5 carbon atom. And the next one possibility is if there is 4 carbon atom in the longest chain and 1 carbon is acting as a branch. So if one, double bond is over here, it's pent, its name is pent 1ene. Its name is pent 1ene. If double bond is over here, its name will be pent 2ene. And if double bond is over here, it's again pent 2ene, over here again pent 1ene. So on this 5 carbon atom longest chain, we are having 2 different alkenes as far as the structures are concerned. Now come toward the stereoisomerism. 1ene compound never show any sort of stereoisomerism. I mean they are counted as a 1 isomer. But in case of pent 2ene, if the double bond is over here, yes, this carbon is having H and this group, this carbon is having H and ethyl group. Yes, it can show cis and tron. Cis and tron. 2 isomer will be over here, so it is equal to 2. On the state chain pentene, there are 3 possible isomers. Those are said to be structure plus stereoisomer. Come toward this one. If there are 4 carbon atom in the longest chain, now number 1, I'm going to put a double bond over here, and in this case, this is 2-methyl. This is, I'm going to write it, I'm sorry. I'm going to write it over here as 2-methyl bute 1ene. If I'm putting double bond over here, that is one and the same thing. So I'm not going to put it over here. If I'm putting double bond over here, then it will be 1, 2, 3, 4. And here this end is more closer to the branch, so numbering will be started from this end. I mean it will be 2-methyl and bute 2ene. If we are putting double bond over here, and now numbering will be started from this end. This is carbon number 1, carbon number 2, carbon number 3, carbon number 4. Now branch is at third position, 3-methyl. It will be 3-methyl, and this is bute 1-ene. Yes. 1-ene cannot show any sort of geometric isomerism, stereoisomerism. 2-ene maybe, but in this case, if this is this one, 2-ene, CH3, CH3 double bond, CH3. So this double bond cannot exhibit cis-trans isomerism at the moment because these two are the similar group. So only these 3 structural isomers are possible. 3 structural isomer, 1 structural isomer that is equal to 4, and 2 that is because of the stereoisomerism. So 1 plus 2 plus 3, total number of possible isomer that is equal to 6. So D is the correct option. Come towards the next question, question number 26. An excessive dry HBr is formed with the compound Y. Dry HBr is formed, right? What is the major product of this reaction? Here are 2 double bonds, and major products mean H will be added to the center, which is having, that is having more number of hydrogens. So H over here and Br will be over here. Upon addition, this carbon-carbon double bond will show addition with the HBr, and same is the case over here. Here are 2 hydrogens. This hydrogen will be given to this carbon, it will become CH3, and Br will be over here. That is according to the Markovnikov rule. This addition will be the highest yield, will give the highest yield. So it is said to be the major product, right? And the next one is this dry HBr is also going to change the, you can say it is going to change the OH group. So it will replace, Br is replaced by this OH group, and here will be the Br. So which one option is the correct option? Which one option is the correct option? CH3Br, CH3Br, hexagonal ring, then Br, then 1 carbon, 2 carbon, and again Br. 1 carbon, 2 carbon. I think C is the correct option. However, this cannot be correct because it is having yet double bond. In this case, CH3Br, cyclohexane, this Br, 1, 2, there must be no any sort of OH group. So I think C is the correct option. However, we can check it over here. No, this is incorrect. There must be a CH3 group over here. CH3 group, Br, and there must be the CH3. So D is incorrect. It is confirmed that C is the correct option. Question number 27. Which reaction would produce propanoic acid as one of its product? Propanoic acid, any sort of carboxylic acid can be made from alcohol. It can be made from hydrolysis of nitrile. It can be made from aldehyde, and so on. So option number one, A option, heating this one, yes, we can also make by decomposition by the breakage and oxidation of carbon-carbon double bond. We can also make the carboxylic acid. So question number 27, number 1, if we are going to heat this carbon-carbon double bond with concentrated acidified KMnO4, let me check it over here, is CH3 and CH3 double bond CH2 and CH3. If this bond is broken by the KMnO4, here will be C double bond O, here will be C double bond O. It's a ketone, and this is propanol. Upon heating with again concentrated acidified KMnO4, this ethanol will oxidize itself. As I told you, aldehyde can also be oxidized. It will change into carboxylic acid, and this is said to be propanoic acid. Yes, it is a propanoic acid. So yes, propanoic acid can be made by the heating this alkene with a acidified KMnO4. So A is the correct option. Question number 28. Compound X is treated with an excess of lithium aluminium hydride. The reaction is allowed to go to completion. So lithium aluminium hydride, and here is the compound X. You know, lithium aluminium hydride is good for the reduction of ketone, for aldehyde, for carboxylic acid, ketone and aldehyde, for carboxylic acid, and so on. Here are the two functional groups. One is the ketone and this one is the carboxylic acid. So these both group will be reduced. So there will be single bond, here will be H, here will be again H. There is no need to show H, however, I'm going to show it over here. And this carboxylic acid will change into alcohol. In primary alcohol, there's a CH2OH, it's a primary alcohol. So which one is the correct option? Which one is the correct option? And it is the D one. It is the D one. The same as over here, and D is the correct option. Question number 29. What is the skeletal formula of the compound when CH3 CH double bond CH2OH is heated under reflux with K2Cr2O7? If alkene is heated in conjugation with alcoholic group, there is no effect on the carbon-carbon double bond because of this K2Cr2O7. That is a weaker, not enough stronger oxidizing agent. So double bond will remain unchanged and this primary alcohol will be oxidized. Its formula should be CH3 CH double bond CH, and this carbon will be oxidized. That is a primary alcohol and it is heating under reflux. So this primary alcohol will change into carboxylic acid. We can change into the skeletal formula. 1, 2, 3, 4 carbons atom are there. 2 carbon, 3 carbon, 4 carbons. There is double bond between carbon number 2 and carbon number 3, and this one is having C or double bond O and OH group. So this is the product that can be made, and the correct option is the B option. This one is the correct option. So B is the correct option. Question number 30. The diagram shows the structure of compound Q. It's a Q, and here it is showing this part is equal to X, this is a Y, and so on. Two of the rings X and Y contains carbon-carbon double bond. Yes. Which row is correct? There are the 4 options A, B, C, D. Which row is the correct one? You can say which row is the correct. Number 1, number of ester group in one molecule of Q. Description of rings X and Y. How many ester linkages are there? 1 ester linkage. This is the second ester linkage. So 2 ester linkages are there. 2 ester linkages. C or D may be the correct options. Come toward the next one. Both are planar, X and Y. Neither is planar. Right. Now let's see over here. Description of the ring X and Y. This X and this is the Y. If the all carbon atom of the ring are sp2 hybridized, then it could be the planar. If the all carbon atoms are these 2 carbon atoms are sp2 hybridized. This is 1, 2, 3, 4. And you can say this carbon is also in conjugation with the sp2 hybrid orbital. So these, 1, 2, 3, 4, 5. These 1, 2, 3, 4, 5, and 6. These 6 carbon atoms are lying in the same plane, are said to be the planar. But both rings are not lying or not going to be in the same plane. So they are not planar. I mean, they both are not planar. So, I mean, it's the correct one. It's the correct one. And D is the correct option. D is the correct option. Now come to the next one, the portion B, that is the fashion of the previous strategy. However, I'm going to solve from question number 31. Carbon and nitrogen are adjacent in the periodic table. Which properties do they both have? Which properties they do both have? Number 1, there is an empty 2p orbital in each atom of the element. In nitrogen, in carbon, no, I think it is incorrect. In case of nitrogen, it is having 7 electron. In case of carbon, it is having 6 electron. So 1s2, 2s2, 2p2 is this the carbon, nitrogen, 1s2, 2s2, 2p3 is the nitrogen. So you can see that they both are using 2p. There is 2p is not empty, so 1 is the incorrect. If first one is incorrect, in this case, definitely 2 and 3 will be the correct option. From this scheme, you can check it over here from this scheme. And so if the 1 is incorrect, if the 1 is incorrect, 1 is incorrect, 1 is incorrect, then only there is only one option, that is the C option. So it's C, I mean the correct option is the C one. The principal quantum number of the highest occupied orbital is equal to 2. Principal quantum number is equal to number of shell. They both are having the 2 shell, and finally the shell is shell number 2. Yes, it is correct. The third one, they can form compound in which their atoms form 4 bonds. Yes, you can say nitrogen in form of NH4 positive ion, it can form 4 bonds. Carbon is, I mean, it is a property of the carbon. At excited state, it is also supposed to make the 4 bonds. So yes, these 2 are the correct option. Question number 32. Which hydrogen bonding present, the strong hydrogen bonding present in liquid water causes an increase in which properties? I mean, because of the hydrogen bonding, which properties are suffered or changed or associated? Viscosity, boiling point, and surface tension. These all are the physical properties. So yes, by increasing the strength of hydrogen bonding, viscosity will be higher, boiling point will be higher, and yes, surface tension will also be higher. So 1, 2, 3, all are the correct option. According to the above scheme, the answer is A, option is A, I mean all are the correct. Question 34. A reaction between carbon and oxygen is shown. Carbon that is going to react with oxygen to make CO. Number 1, how can the standard enthalpy change for this reaction be described correctly? Standard enthalpy change of formation, yes, it is true, because 1 mole of the carbon is going to react, and you can see it over here. 1 mole of carbon is going to combust with, going to react with oxygen to make 1 mole of CO. Yes, it is the enthalpy change of formation. Both elements are going to react to make 1 mole of a compound. So it is correct one. The next one is enthalpy change of combustion. Apparently, it looks like that carbon is going to combust, but there is the incomplete combustion. Combustion should be complete combustion. There must be the complete, and it is not the complete one. So according to the standard conditions, according to the standard definition, this equation cannot be called as standard enthalpy change of the combustion. So if the 2 is correct, definitely third one will also be the incorrect. If 2 is incorrect, then 3 will be incorrect as well. Standard enthalpy change of atomization. Atomization is only supposed to make the elements only, and this is not the case. So 1 only, I mean D is the correct option according to the above scheme. Question number 34. Hydrochloric acid reacts with zinc. HCl plus zinc goes to ZnCl2 plus H2. What will increase the rate of reaction but will not change the Boltzmann distribution molecular energies? So rate of reaction, a parameter that is going to change the rate of reaction, but it will not change the Boltzmann distribution molecular energies. It will not change the molecular energy. Option number 1, adding the addition of suitable catalyst, yes, it is true, it will increase the rate of reaction, but it will not change the energy. It will decrease the energy of activation. It will decrease the barrier of the, or it will lower the barrier of energy of activation. The next one is an increase in concentration of HCl. The concentration of HCl will be higher in this case, and in both cases the Boltzmann distribution curve will not change. Boltzmann distribution curve will not change. Increase in temperature, no, it will change. So 1 and 2, B is the correct option. Question number 35, B is the correct option. The element astatine is below iodine in group 17 of the product table. Which statements concerning astatine are likely to be correct? Number 1, it's dark color solid at room temperature. Yes, as we move from top to bottom, color becomes darkened. So yes, it is correct. The second one, it is more powerful oxidizing agent than iodine. No. The bottom element are less powerful oxidizing agent. So it's incorrect. 2 is incorrect. 1 is correct. And its hydride is more thermally stable than HBr. Its hydride is not more thermally stable. It is less thermally stable. As we move down the series, the bond length increases. Right? Bond length increases, and hydride, the decomposition becomes, or the thermal stability is less one. Our decomposition will be more easy or more feasible. So it's again incorrect one. So one and only, according to the above scheme, D is the correct option. Question number 36. Which statements are correct? Aluminium chloride dissolved in water to give an acidic solution. Yes, it is correct. When AlCl3 is allowed to react with H2O, there is the formation of aluminium hydroxide and HCl. AlOH thrice, generally speaking, and there is the formation of HCl. You can say 3 mole of HCl, yes, it is true, and so on. So first one is the correct option. Magnesium chloride dissolved in water to give the solution of the pH close to 7. When magnesium chloride is dissolved into the water, its pH is equal to 6.5. 6.5, that is close to 7, so again this is correct. Sodium chloride dissolved in water to give an alkaline solution. No, it's not correct. Sodium chloride gives neutral solution. 1 and 2, again, B is the correct option. 37, ethanol and hydrogen cyanide react together. The reaction mechanism involves cyanide ion. In this case, cyanide ion is going to attack on this carbon atom, and this is the intermediate, you can say, and this is the final product. Which statements about these mechanisms are correct? Cn negative ion is acting as a catalyst. Yes, this Cn negative ion is acting as a catalyst, and it can be seen from this picture because it is going to retrieve itself at the end of a chemical reaction. Cn negative ion is a nucleophile. Yes, it is nucleophile because it is attacking on this carbon atom that is said to be electrophilic carbon. And yes, it is said to be the nucleophile, and this carbon is said to be the electrophile or electrophilic carbon. The last one is, it is an addition reaction. Yes, it is an addition reaction because this is said to be nucleophilic addition. So all options are the correct option. A is the correct option or the correct answer. Question number 38. Which compound will produce yellow precipitate with alkaline aqueous iodine? That is iodoform test. And there is only one aldehyde that can show this type of test. Alcohol that is having OH group on the second carbon atom. One is the methyl, and here is alcoholic group, CH. It may be H and the carbon chain. And ketone, those are said to be the methyl ketone. So these sort of compound will show positive test, will react and give the yellow precipitate. Here is the ketone, but this one is not the methyl ketone. There must be a methyl group on one side of the ketone. So it will not react. Again, this one is a tertiary alcohol. I told you there must be one methyl, one hydrogen, and over here these two type of groups should be there, and this carbon if this carbon is having the OH group. So this alcohol gives us the positive test. So one is not going to give the positive iodoform reaction. I mean, it is not going to make the yellow precipitate. So 2 in case of 2, yes, I mean 2 and 3 will be the correct one. This is CH3, this is C, and this is H. So this alcohol, and this, because of this alcohol, not this alcohol, because of this alcohol, yes, it will give the positive test. I mean, yellow precipitation will be there. In this case, because of this alcohol, yes, it is CH3, HCH, HCH3, and C is having OH group. Yes, because of this alcohol, the third one, it will show this test positive. So 2 and 3, C is the correct option. Which statements apply to the tetrafluoro? It's a tetrafluoromethane. It's a tetrafluoromethane. It is readily decomposed by the ultraviolet radiation. No. In the presence of ultraviolet radiation, the decomposition is of CCl bond. CCl bond readily decomposes itself in the presence of UV light. So first one is the incorrect option. It is less harmful to the ozone layer than dichlorofluoro. Yes, because there is less chance of formation of radicals, and it cannot be decomposed by the ultraviolet radiation. So yes, it is true. It's a non-polar molecule. If the central atom is having all bond around it, sigma bond, covalent bonds, and all atoms are similar, same. So yes, this molecule is non-polar. If the central atom is having, I mean, all sigma bond, there is no any sort of the lone pair. Number one. Number two, all atoms are the same atoms, same group of atoms, so it will be non-polar. Its dipole moment will be equal to 0. Yes, it is. I mean, it's a non-polar. Yes, it is true. So 2 and 3, once again, you can say C is the correct option. Question number 40. A statement comparing ethene and ethane are correct. Bond angles in ethene are larger than bond angles in ethane. In ethene, the bond angle is equal to 120 degree. In ethane, bond angle is equal to 109.5 degree. It's a 120 degree, it's a 109.5 degree. I mean, yes, it is larger, greater, yes, it is true. Ethene reacts much more quickly with bromine in dark than ethane does. Yes, this is the test of unsaturation, and in dark, because of the presence of this pi bond, this double bond, it reacts with the bromine in dark. Yes, it is true. Complete combustion of 0.01 mole of ethene or ethane produces the same volume of the gas measured at room temperature. When these both are supposed to react, C2H4 and C2H3, they are combust, I mean with oxygen. At room temperature, they will make carbon dioxide. They both will make carbon dioxide and water. At room temperature, water is liquid, only CO2 is over here. How much CO2 should be there? If the 1 mole of or 0.01 mole of C2H4 is going to combust, then there will be 0.01 mole of CO2. If 0.01 mole of ethane is allowed to combust, CH6, and then it will make 0.01 mole of CO2. Yes, 0.02, I'm sorry, 0.02 mole of CO2, and in this case again 0.02 mole in both cases. I mean, this 2 will be multiplied with this one, 2 will be multiplied by this one. I mean, they both are having the same number of carbon atom, so they both will make 0.02 mole of CO2, and it will also make 0.02 mole of CO2. So these all are the correct option. I mean, A is the correct option. So it's all about this paper. Thank you very much. Have a nice day.